Welcome back to my channel. Hello students. Today we will discuss about some more discussion regarding the motion of an object. However, in the last class we discussed that whenever we talk about motion, it is related to a reference point, and then we jumped to relative motion. That motion is not absolute quantity, rather it depends on the reference point that you take. So from that point we now start. Some questions may be popping up in your mind, that how motion can be measured, how it is related to time, say another physical quantity, or what is the what are the different types of motion that are there. So all these questions we will take one by one. So let's start with the first one. Suppose you are moving from your home to school, and you are going through by road, and you are catching up with your friends, and then you reach your school, and your friend asks you that how did you come. So you would say that I moved from home to school, or would you like to have some quantification, or you can say that I walked around 20 meter or 30 meter to reach the school. So here we come to the fact that what is this 20 meter or 30 meter. So this is actually the distance covered by you from home to the school. Now the length of the actual path covered by you may be having turnings and maybe having a lot of obstacles around. However, the distance is measured as the actual length of path taken by you. Now we come to the fact that are there any other means by which you can measure the distance. So of course we have another means, say straight line path between the home to school. Now this is the first depiction of what we are talking about. Suppose you started from position A and reached position B through covering the distance. Then what is the straight line path between A and B? You can draw directly from point A to B. This is the shortest distance between the 2 points. You may learn it in your mathematics class, that what is the shortest path between 2 points. It is a straight line. So this is what we are depicting here, the length of the actual path and the shortest path between A and B, where A is your home and B is your school. So we talked about that I walked 30 meters, say. Now you can also say that from where did you start? You started from home, so that is the initial position, and you reached final position. For the measurement of the shortest path, what do you require? You require the initial position and the final position. So this, what physical quantity we can have for this? There is the quantity defined as the displacement of an object. What is the displacement of an object? It is the shortest path between initial position and final position. So this is what is depicted in this, that initial position is your home and final position is your school. Now we come to the next point, that does these quantities have any quantity, which is displacement. So besides distance, you can also measure the distance as displacement. Now a question may arise that what is the difference between distance and displacement. So distance is the actual path covered and displacement is the shortest path that you join a straight line path between initial position and final position. So this is a very basic difference between distance and displacement. Now we move to another example where you would have to think that what is the difference between distance and displacement. So let's take another example. Suppose you take a elevator and move from ground to the third floor, and then you come back from third floor to the ground. Now you would say that how much, say the height of the elevator is 10 meters, then you would say that how much did you travel. So you would say that I traveled around 20 meters, and that would be the actual length of the path covered. But we would see here that what is the initial position for this? The ground floor is the initial position, whereas the third floor is the final position while going up, and while coming down you have ground floor as the final position and third floor as the initial position. So can you figure out going any difference between going from ground floor to third floor and coming back from third floor to ground floor? You would say that yes, the difference is that we moved up, and in the second case we moved down to the earth. So this means that this would give you another idea that displacement or the shortest path must have initial and final position together with the direction of the motion. So we can have another difference between distance and displacement, that is distance is the actual length of path covered, whereas displacement is the shortest path between straight line path between initial and final position. And the second difference is that distance doesn't consider any direction. You turned left or you turned right in the road, on the road, and it doesn't consider any direction. So however, when it we talk about displacement, it covers the direction also together with initial and final position. Did any question pop up in your mind that what you said that it is going up and then coming down? So of course there is a difference. In the first case, the initial position is ground floor and final position is third floor. And in the second case, while coming down, initial position is the third floor and final position is the ground floor. Now, can you figure out what is the displacement in this case? Of course, the height of the elevator, if taken 10 meter, then the distance traveled is 20 meter. What about displacement? So this next slide is just presenting you that actual path covered always increases, whereas displacement may decrease. And what would be the displacement in case of elevator? The initial and final position both are the ground floor, that means the displacement is 0 in this case, and we conclude that displacement can be 0 or displacement can be equal to distance. So this is the basic another difference between distance and displacement. So Displacement requires both magnitude as well as direction, whereas distance doesn't require direction. So here we can just have a quick idea about what are the differences between the distance and displacement. So first is the actual path covered, second is the shortest path between straight line path between initial and final position. The path of the distance is independent of the route taken or the direction, whereas path of the displacement considers the initial and final position. Then the distance adds up, always adds up and increases, whereas displacement can cancel out and become zero. It requires distance require only magnitude or value, whereas displacement require both magnitude and direction. Now I hope you have understood what is the difference between distance and displacement. Now let's have an audio regarding these points.
So think about this. Whenever you go from one place to another, how do you actually measure that trip? It seems like a super simple question, right? But the answer, well, it can be really different depending on what you're actually trying to figure out. Today, we're going to break down two really fundamental ways to measure motion: distance and displacement. Okay, let's make this real. Picture this, you just walked to school. Easy enough. If someone asked you how far you went, what would you even say? It feels like there should be one simple answer, but as you're about to see, it all depends on your perspective. Alright, for any journey, you've got to have a starting point, right? So for our walk, that's going to be home. We'll just call it position A. Think of it as our anchor, the spot where everything begins. Now, unless you can walk through walls, you probably didn't go in a perfectly straight line. You walk down your street, you probably turn a corner, we'll call that position B, and then finally you arrive at school. That whole winding route, that's the path you actually took. And if we could, stretch out a giant measuring tape and lay it down along every single step and turn you made, let's just say the grand total comes out to 30 meters. And not 30 meters? Well, in physics, that has a very specific name. It's the distance. It's pretty straightforward. Distance is the total ground you covered. It's the literal length of the path you walked from your front door to the school's front door. But what if we don't really care about the scenic route you took? What if all that matters is how much your position has changed? Is there maybe a more direct way to talk about your trip from home to school? Imagine for a second that you could just draw a perfectly straight line, like a laser beam, right from your starting point home directly to your end point, school. No turns, no corners, just a direct shot. And that direct straight line measurement is what we call displacement.
So this video is also telling about what is the difference between actual length covered, whereas if we take initial and final positions only and draw a straight line, the shortest distance, that is displacement. So there is a difference between distance and displacement.
Now here's the key. Displacement totally ignores the winding path you actually walked. It only cares about two things. Where did you start and where did you end up? That's it. So there we have it. We've got two completely different ways to measure the exact same journey. One is all about the path and the other is all about the position. Let's put them head to head. Okay, look at this. It's actually pretty simple when you see it side by side. Distance measures the actual path you took. So if you decide to take a long, rambling detour, your distance gets bigger. But displacement, it only measures the change in your position. It doesn't care about your detours. As long as you start at home and end at school, your displacement is going to be exactly the same. So here's the crucial point, the way to really remember this. When you think of distance, think of the odometer in a car. It clicks up for every single meter you drive, no matter what direction you're going. It's all about the total journey. But displacement is way more like a GPS giving you the as the crow flies route. It's that straight line. It couldn't care less about the roads or the turns. It just calculates the shortest, most direct path from where you were to where you are now. Okay, now for the really cool part. This all leads to a fascinating little puzzle. Let's say you walk that 30-meter path to school. And then, at the end of the day, you turn around and walk that exact same 30-meter path all the way back home. What have you actually measured? Let's really think about that for a second. The distance, that part's easy, right? It's 30 meters there and 30 meters back, so you've walked a total distance of 60 meters. Simple. But what about your displacement? Remember, displacement only cares about your start and end points. You started at home, and where did you end up? Back at home. Your final position is identical to your initial position. So what's your displacement? It's zero, a big fat.
So in this case, in the later part of the video, it is describing the difference between distance and displacement, that you walked from home to school and came back to home, then you have traveled around 30 meters plus 30 meter, that is 60 meter of distance. However, what about the displacement? Displacement is the distance, is the path between initial and final position. Since you came back to home, so the final position and the initial position become same, and you say that displacement is zero in this case. So in this way we can figure out that how the physical quantity may be different. So in the next session we will consider what are the different types of physical quantity and move further, that how the motion can be related to time or some other physical quantity.